Going through an old notebook that I found recently, I found these two fabulous brochures on the Cary 14 and the Cary 17 unit spectrophotometers. This one dates to the 1960s. Check out the white shirt, probably with a black tie. And this one dates to the late 1970s. Notice we've updated now to a nice checked shirt. And these are extraordinary instruments that, again, date to the 60s and 70s, and yet are still being used, many of them in their original form with these strip chart recorders on them, and hundreds of others which have been modernized to operate under modern computer control. Over the decades, there's been two companies which have worked with these instruments, mine being one of them. So what makes these spectrophotometers so extraordinary that 50, 60 years later, they're still considered to be the best in class? Starting with the Cary 14, with a prism grading double monochromator rapidly and accurately recording spectra in the ultraviolet, visible, and near-infrared range. Because of its exceptional performance and long-term reliability, the instrument is considered by many to be unexcelled. Rather than equipment limiting the scientist, it allows him to work to full capacity. Special care has been taken to incorporate systems and components in the instrument, which will give superior resolving power, high photometric and wavelength accuracy, and high light purity, plus versatile and operational conveniences. In the physical science and life science fields, the instrument has proven itself an indispensable tool. Routine tasks as well as fundamental research studies are easily within the capability of the instrument. The standard 14 can be used for fixed wavelength kinetic studies and for recording absorbance or transmission spectra. Linear and wavelength, numerous standard and special accessories are available to adapt the spectrophotometer for almost any type of investigation. If we go now to the 17 brochure, and here's a very good photograph showing the strip chart recorder, the multi-pot unit, the original sample compartment, which is a true beam sample reference detector chamber. Really an extraordinary instrument. And to identify, again, a bit about the performance and so forth inside the Cary 17. To realize the best possible performance, individual components are carefully designed to tight specifications. As a result of exercising such care with each subunit, the spectrophotometer gives the user unmatched performance and adaptability. The only component I want to read here, because nearly all the rest of them have been replaced with modern alternatives, but the reason that we use these instruments and that people keep coming back for them is the heart of the Cary 17 and it's the same for the 14, is a double prism monochromator. So the dispersing elements in the monochromator include a 30-degree fused silica prism and a 600 line per millimeter grating. The prism offers high optical efficiency plus low scattered light, while the grating provides high resolving power and a low temperature coefficient of 0.03 nanometers per degree C at long wavelengths. The dispersion of the prism and grating are additive. That is, the narrow band of energy passing from the prism through the intermediate slit is further dispersed by the grating, and a highly monochromatic beam exits the monochromator. Both the prism and the grating halves of the monochromator operate with an aperture ratio of f8. The columnator associated with the prism has a focal length of 30 centimeters, while the columnator for the grating has a focal length of 40 centimeters. Since the slits are 2 centimeters tall, high light scattering power results from the large slit height to focal length ratio, plus the efficiency of the optical elements used throughout the monochromator. Resolution in most of the UV range is 0.1 nanometers, in the near infrared about 0.3. Stray light is held to less than 0.0001% between 240 and 500 and 0.001% between 210 and 1800. And even the wavelength range limits stray light does not exceed 0.1%. The excellent light purity allows the instrument to measure at absorbance values greater than 4. Of course, we don't recommend working at, such a high absorbance, but the possibility exists. So what is spectroscopy used for? Applications in the UV visible. Different spectra, electrochemical spectroscopy, far UV, high temperature, high pressure, kinetics, low temperature, luminescence, near infrared, photochemistry, polarization, reflectance, scattered transmission, solid samples, thermodynamics. And in this book are many of the early papers, 1966, 1974, 1970, etc., including the names of many of the scientists who came came to my company for the modernization of their instruments. Ron Broderick, T.C. Bruce, many of our instruments, the Bonaventures, Celia and Joseph, David Buckingham, Jim Espenson, Joseph Mickle, Harry Gray, many of his labs graduates have instruments using the same optical bench, the Cary 15. Where else do we have here? Greg Chopin, another laboratory that put out many huge enthusiasts of this marvelous monochromator. Galen Stuckey, Larry Kay. So what does a modern instrument look like that has a Cary monochromator? Well, here's one example. This part is, of course, the optical bench, that double prism grating monochromator, which extends all the way out to here. And in this particular configuration, we've replaced the original sample compartment with our sample compartment for polarization studies and an emission monochromator. So this particular unit is not only useful for UV vis near infrared absorbance spectroscopy, but also circular dichroism and circularly polarized luminescence. So if you'd like to learn more about any of this that we've discussed today, please be in touch.